When you want to use more than one independent or predictor variable in order to predict another variable, then you'll have to do a multiple regression. Multiple meaning that you have multiple predictors or multiple independent variables, and regression meaning that you want to predict something. So I'm going to be using GPA, how students did in the first quiz, and how they did on the final exam in order to predict their final percent grade. To do this, you go to Analyze, Regression, and then Linear. You place your dependent variable in the dependent box, and you place all of your predictor variables in the independent box, all your predictors. In statistics, you should request descriptives. And for now, I'm going to leave everything the same. This method, enter, is what we'll be talking about. Press OK. And now we'll get the descriptive statistics plus a correlation matrix for all of the variables in the analysis. And here we get which variables are entered and removed in our model. So we have one model. And the reason why we have one model is because we have used the enter method. This is a method of forcing all of the predictor variables, all of the independent variables to be in the equation, in the final equation, or in the final model. So in this case, we have no reason to enter and remove variables because we're entering all of them at once, and we're forcing them to be part of the equation, whether they're significant predictors or not. Then we get our model summary, and this tells us the correlation between the linear combination of all the independent variables with the dependent variable. So you can see that these are all of our correlations here, and this does not match any single correlation. That's because it's not a particular pairwise comparison. What it's actually doing is calculating some sort of composite variable from all three of the predictor variables and then correlating that composite variable with final percent grade. So it gives you an idea of the overall model, the relationship between the predictors and the dependent variables. After that, we get the ANOVA, which tells us the significance of our model. Here it says that our regression is significant, so our equation is a good representation of the data. And then we get our coefficients. And what our coefficients tell us is the relationship between each individual predictor and the dependent variable. Over on this side, you get a t and a p-value. This is telling you whether each independent variable or predictor is significant. So it turns out that GPA is not a significant predictor, whereas quiz 1 and how they did on the final exam do significantly predict final percent grade. So some people may question why we want to include GPA in the model if it's not actually significantly predicting final percent grade, and this is a valid question. Not many people use the enter method, and SPSS will give us other methods of entry. So to go back into the regression dialog, you can see that this drop-down menu gives you multiple ways of conducting this analysis. So I'm going to start with the simplest one here, which is the forward method. And what the forward method does is it starts with a model where nothing is entered in the equation. And then it'll choose the best predictor and enter that in the equation, and then the second best, and so on. So all of the variables start outside, and then they're entered one by one. And if a variable does not make a significant difference, then it's not added. So to run this, we're going to get basically the exact same output, except we'll get multiple models. So just looking at the correlations between final percent grade and GPA in quiz 1 and final, you may expect that final, or how they did on the final exam, is the best predictor of final percent grade because it has the highest correlation. So looking at the variables entered and removed, you can see that now we have two models. So it starts here and it picks the best predictor to add. So they all start outside the model, and then SPSS chose the best predictor based on this, the highest correlation, to enter in the model. So it's entered final exam into the model. It ran that model and then chose a new predictor to add. And out of the ones remaining in the second model, it added quiz 1. So in this model, we have final exam, and in this model, we have both final exam and quiz 1. After that, it didn't decide to run any more models, which means that this last row, whenever you have multiple models, the last row tells you what your final model is. So in this case, it decided not to enter GPA into the final model, which makes sense because our previous analysis showed that it wasn't a significant predictor of final percent grade. It gives a model summary for both models. Just keep in mind that the bottom one is your final model. Next, we can see the significance of our final model. It is significant. And then we get our coefficients. And here we get the values we need to construct an equation, and we also know that both of these are significant predictors of final percent grade. We also get excluded variables table, which essentially gives you a list of the variables that were not included in the equation in each version of the model. So in the first model, we just had final exam. That means that GPA and quiz 1 were not in the model. In the second model, we added quiz 1 to final exam, which means that only GPA was not in the model. And this is our final model. So it gives you a little summary of which variables are included or not included in the analysis. So going back into the regression dialog, I'm going to briefly show you the backward one. And this is easy to understand because it's the exact opposite of the forward model. So instead of all of the variables starting outside of the equation, they will all start inside the equation and then be removed one by one. So press OK, and we'll just take a look at how the model changed. So you can see here, in the first step, all of the variables were in the model. So they all start inside the equation. And then any sort of non-significant predictors are removed from the model until you get to the final model. So in this case, we've basically come to the same conclusion that GPA should not be in the model, but it's gone through a different method to get there. This is all read the same for excluded models, and also the coefficients and whether it's significant. And you can see that most of these methods are going to come to the same conclusion. It just uses a slightly different method. Both of those methods are, I would say, not that common. Probably the most common is stepwise, but in order to understand this, you need to understand both forward and backward, which is why I covered it. So with a stepwise method of entry, your variables can go in and out of the model. So with forward, they can only go into the model. They can't go back out once they're in. And with backward, they can only go out of the model. They can't go back in once they're out. But stepwise will basically do all sorts of iterations in order to find the best model. In this case, we don't have too much variation in the variables that I have access to, but you can see that it comes to the same conclusion as both of the other methods. So in our final model, we have final exam and quiz 1. But if you have a lot of variables and the relationships between them are more complex, then you may see that some variables are first entered and then removed in later stages, and you might have many more iterations of your model.